Hello, in this clip we look at saturation and unsaturation of hydrocarbons. Welcome. The term saturation simply means the tendency of a molecule not to have room or space for additional bonds. Therefore, when we describe a molecule of organic form as saturated, it simply means it's made up of a complete ring of 4 single covalent bonds in which there is no room for any additional bonds. Let's take the example of methane. And in this case, I would want to classify it first and foremost as saturation. And we have said saturation is a state in which each carbon atom holds a chain of 4 single covalent bonds. In this case, it's a ring. So, saturation is a state in which each carbon atom holds a ring of 4 single covalent bonds. And in this case, they have no room for any other bonds. Therefore, using the example of methane, which is 1 carbon with a chain, a ring of 4 single bonds, and ethane with 2 carbons and a ring of hydrogen bonds, then we could say that they are saturated simply because an attempt to bring an external species like X meets no room for addition. The same thing will happen with the ethane molecule, which has no room for addition, no room for new bonds. And when there is no room for new bonds, we say it is saturated. And we are going to see in the next clip that when a molecule is saturated, the only type of reaction it can undergo is substitution, simply because there is no room for addition. So the only option is for it to replace any one of its hydrogens through the process of substitution. Now, B, we have said some molecules are unsaturated. What is an unsaturated molecule? The unsaturated molecule is one in which there is a double bond or a triple bond which is breakable to allow room for additional bonds. In this case, we can say that unsaturated means having a breakable double or triple bond for new additions. For example, we may take ethene, which has a double bond, and in this case, when you bring a foreign species like a halogen to ethene, the middle bond is breakable, and when you break it, it's reduced to single bond, and the consequence is a new attachment of the halogen. The new attachment creates polarity of one of the carbons where there is a delocalized electron. A second halogen may approach and join in that respect. Therefore, it's clear that during the reaction of an unsaturated hydrocarbon the breakable bond is broken, and when a single bond is broken, two principal points are created. The first is the one in which an attachment has joined, and the second in which has been polarized, creating room for any other additional bond. Therefore, anytime you break a bond in a double bond, you create two principal points for addition. It follows then that should you have a triple bond, such as that in ethyl, then the sequence will be as follows. Assuming I have my ethyl with a triple bond, assuming then that I bring in a halogen such as bromine, the first effect will be the breaking of the first bond, creating two principal points for addition. The second will be breaking the second, creating two other principal points, and the ultimate result will be the creation of a single bond with four principal additions. In this case, each breakage creates two principal points, and we end up with a 1, 1, 2, 2 tetrabromo ethane, which is rendered saturated after the breakage of the unsaturated molecule. And therefore, in summary, we have said that organic compounds may exhibit saturation. When an organic species is saturated, it carries exclusively single bonds which are non-breakable and have no room for addition. When a hydrocarbon, on the other hand, has a double or triple bond, the double or triple bond positions are breakable, creating room for addition, and therefore we say they are unsaturated. Examples of saturated hydrocarbons are the alkanes and the alkanols, while the examples of the unsaturated molecules are the alkenes and alkynes. Thank you very much. That has been a description, briefly, of saturation of hydrocarbons. In our next clip, we are going to evaluate what is known as the reactions of saturated and unsaturated hydrocarbons, namely through substitution and addition processes. Thank you.